As promised in an earlier video, let's actually go ahead and prove this formula here that relates together the angle between two vectors and the dot product between them. So how do we actually prove them? The answer here is going to be the law of cosines. This is something that you probably ran across in a high school trigonometry class. What does the law of cosines say? So it's going to be c squared is equal to a squared plus b squared minus 2ab times cosine theta, where I need to draw a triangle here to illustrate a, b, c, and theta. So this is going to be my triangle. I'm going to have sides A, B, and C. Those are the side lengths there. And theta has to be the angle that is opposite of C between A and B. So this is a law of cosines. Again, you should have seen this in the high school trigonometry class. I'll just make one brief little comment here. If theta is equal to 90 degrees pi over 2 radians, then this is a right angle here, A, B, and C. And what happens is that cosine of theta is equal to, the cosine of pi over 2 is 0. And so this just becomes c squared is equal to a squared plus b squared. And I think we recognize that. That's just the Pythagorean theorem. So what's the law of cosines? It's a generalization of the Pythagorean theorem. Okay, so back to work here. Let's do this for vectors here. I'm going to draw a picture. I'm going to draw, suppose this is our vector v. Suppose that this is our vector w. I'm drawing them coming out from the same point here. And then I need a third vector here. This one right here, this is going to be v minus w. Realize here that if we do w plus v minus w, that ends up with v. Check out yourself that everything there checks out. So what we're going to do is let's apply the law of cosines here. So theta is the angle between v and w. Let's apply the law of cosines here, where this is a, this is b, and this is c, or rather the length of v. The magnitude of v is a, the magnitude of w is v. Is magnitude of w is b. The magnitude of v minus w is c. What does that give us? So the magnitude of, so let's see, magnitude of v minus w squared is equal to a squared, magnitude of v squared, plus b squared, the magnitude of w squared, minus 2ab. A is magnitude of v, magnitude of w times cosine theta. Okay, so this is what we just rewrote the law of cosines in terms of the magnitudes of v, w, and v minus w. Okay, I need a new slide here. Okay, magnitude of v minus w squared is going to be, that's going to be v minus w dot product v minus w, right? Because the magnitude of any vector is just the dot product of that vector with itself here. And if we distribute, if we FOIL, we would get v dot v minus v dot w minus w dot v, minus times minus is plus w dot w, and dot product, commutative law for dot product, w dot v is just v dot w, so this is just going to be 2 times, v dot w. And of course, v dot v is just magnitude of v squared. W dot w is magnitude of w squared. So if we pull back over, what is this equal to? Let's recopy this, and there's going to be able to see some cancellations. So this is from the previous slide, equal to magnitude of v squared plus magnitude of w squared minus 2 magnitude of v, magnitude of w, cosine theta. Okay, we get some cancellations. Those cancel, and those cancel. And so what are we left with? Negative 2 v dot w is equal to negative 2 magnitude of v, magnitude of w times cosine theta. And we are basically all done. Divide out by the negative 2's and divide both sides by magnitude of v, magnitude of w to get cosine theta is equal to v dot w divided by magnitude of v times magnitude of w as desired. So yeah, nice little application of the law of cosines here.